Oh well. Alright, so, like I just mentioned, we're going to talk about line of best fit today. What's going to happen is they're going to give us points and we're going to plot them. And we're going to try and make a line that best fits all those plotted points. Right? Before we can do that though, we want to talk about correlations. So correlations. What do you think correlation is? What does that mean? Nothing? It means nothing to you guys? Like if I say negative correlation.
Like the same.
They all have something.
Like the same, right? They have the same direction, right? A perfect negative correlation would be all of our points are in a perfect line going straight down from left to right. A perfect positive correlation then, you think it'd be going up from left to right. So it's what direction the same, almost like their sameness. It's not really a word, but like you look, no correlation here because those points don't have any direction to them. There's no reason they're going, right? So what we're going to do today, like I said, we're going to plot some points. We're going to try and figure out what kind of correlation it has. And we're going to try and make a line based off that correlation, whether it's going to be a positive sloping line or a negative sloping line. And we're going to make what we call a line of best fit. All right? So to do that, approximating a line of best fit or a best fitting line, first step is going to be we're going to draw a scatter plot. Like I said, they're going to give us certain points. They're going to give us an x and a y value, and we're going to create a scatter plot based off that. Then we're going to sketch a line that appears to follow most closely to the trend given by the data points. That trend is the correlation we just talked about. If it's trending positively, we're drawing up a positive slope. There should be about as many points above the line as below it. So when we draw it in, we're going to try and get it as close to the middle as we can. Now, is that going to be a perfect science?
No.
No. And actually, if you do a problem like this on the test, who knows if there will be or not, your answer may be different than the answer on my answer key. That's perfectly fine. Because you may pick different points than me to use. You may have just a slightly different line of best fit than me. That's perfectly fine. Right? So it's an approximation at best. Then step 3, we're going to choose 2 points on the line and estimate the coordinates of each point. Now when I do it, I can pick 2 points that I've already plotted so I know their coordinates. You don't have to. I would highly suggest it, however, because otherwise you're kind of guessing and approximating even more than you would be before. And lastly, you're going to write an equation of a line that passes through the 2 points from step 3. It sounds like a lot of stuff to do, but it's really not that bad. Okay? Cool? Alright, let's try it out. So first we're going to talk about how people go to the swimming pool. Talk about the temperature on each day. So like day 1, it was 20 degrees. There were 280 people there. It's kind of cold for the pool, isn't it?
I mean, it's Celsius.
Celsius. Can't trick you guys. So, what we need to do is, first step, draw a scatter plot. Well, to do that, I'm going to first label my graph here. I'm going to go temperature on my x-axis. I'm going to go number of people on my y-axis. Now, am I going to have a nice scale that I can get up to like 500 between here? No. So what we can do is we can actually jump our graph. You guys ever done this before? Yeah? Some of us have, some of us haven't. So what's going to happen is we're always starting at 0 here in the corner. We can draw this little sign. It's almost like kind of like a lightning bolt, but that's giving us a jump in our graph. So we can start with whatever scale we want from there and from whatever number. It's telling us we're skipping that part because we're not going to have any important information in there. So what I'm going to do is I'm going to start with 250 here. And every other one I'm going to go up by 50. 350, 400, 450, 500, 550. Now, if on the test or on a homework or something, you just go right from 0 to 250 and you don't put that little sign, it'll probably get marked wrong. Actually, you can't just start with a different scale than normal. This tells you that you're jumping a part of your graph. Alright, then I'm going to do temperature, same thing. I'm going to start with a little jump here. I'm going to start at 20. I think I went by 4. It's 24, 28, 32, 36, 40, 44. Now, does yours have to be the exact same as me?
No.
No, of course not. Right? It's your judgment of how you want to make a scale. Now, it needs to be a constant scale, right? Just like any graph. And you need to show me like where you're beginning, things like that. Okay? So, Step 1 we said make a scatter plot. So 20, 280. 20, right about here. 280. And this isn't perfect. These points are plotted by approximation. Right? We're guessing at best. 24, 360. 24, 360. 36, 450. 32, 420. For laughing. 28, 400. 38, 500. 34, 475. And then 26, 320. Alright, so you make your scatter plot, right? What type of correlation do you see there? The negative or positive?
Positive.
Positive, right? We're looking left to right, it's going up. So what we're going to do is we're going to try and create a line of best fit based off 2 points that we have. Alright? So what I did is I ended up actually taking the first and the last point. And you're going to take a straight edge, and you're going to draw a line through those 2 points. Right? Remember, when we're drawing your line of best fit, does it have to be the same points as me? No. It's your approximation. Right? So you need to show your work as you do it, though. So you want, as you're going to draw your line, you want about the same number above your line as below. And you want about the same distance from each other. So in this case, I have 3 points above my line, 3 points below my line. Alright? So that's my line of best fit. If you want it to be the same, perfect. If you want it a little different, that's fine as well. Alright? It's your line of best fit. So what I'm going to do now is I'm going to try and make an equation for that line of best fit so I can approximate stuff. Does that make sense? Have I lost anyone yet? We're good? So, for an equation, what do I need? What do I normally need to make an equation of a line? You need slope, then either a point or a y-intercept, right? Let's worry about slope for right now. The reason I chose 2 points that I've already plotted is because I can take those 2 points and I can find my slope using those 2 points, right? My 2 points were, what was that? 38, 500, and 20, 280. Right? We know a formula to find slope off of 2 points, don't we? Yeah, y2 minus y1 over x2 minus x1. So that's the first step, is let's find our slope. 500 minus 280 over 38 minus 20. Well, we get 220 over 18, which I think reduces to what? 110 over 9. For the sake of writing an equation, I'm going to change it to a decimal. I'm going to round it, right? So what do you get? Let's round to the 10th place. 12.2. So my slope is 12.2. Okay. So we said we need the slope, and we need either a y-intercept or a point to be able to make an equation. Do we have either of those, y-intercept or a point? Yeah, we have a point that's on the line, right? We have 2 of them right here. So what we're going to do is we're going to use our slope, and we're going to use one of our points. I'm just going to use the bottom one. And I'm going to find an equation here. Y minus y1 equals m times x minus x1. I'm going to put it in the point slope form. Okay? So y minus 280 equals 12.2 times x minus 20. Now what I'm going to do is I'm going to change it into slope-intercept form. Because when we do linear regression in the calculator, it's going to give it to us in slope-intercept form. We're going to compare our line of best fit to the linear regression out of our calculator. Okay? So let's just make this into a slope-intercept form quick. Y minus 280 equals 12.2x minus, what was that?
244.
244, thank you. Then I add 280. So y equals 12.2x, the plus
36.
36.
Yeah.
So that is my equation for my line of best fit. So what that tells me now is I should be able to approximate how many people are going to be at the pool if I know the temperature. So I can plug the temperature right in for x, and I should be able to approximate how many people are at the pool. Alright? Now, we're going to do it in our calculator in a second, and it's going to do its own line of best fit, but it's going to have really, really close calculations. It's probably a better estimation than us. Alright? So what I want you to do now is there's another problem right below it. I want you to try making a line of best fit for yourself. Now, like I said, when I do it on the board in a second, it may not be the same as you. That's perfectly okay. However, it should be somewhat close to me. It shouldn't be too far off. Shouldn't have too many variables in it. Right? If you get stuck, if you have a question, please ask me. That's what I'm here for. So take a minute or two, plot your points, pick your line of best fit, and then create an equation based off of 2 points on your line of best fit. Okay? Cool? Now, it just so happens that the 2 points I picked in the first problem and the 2 points I picked in this problem are ending up being the first and the last point. It won't always be like that. It doesn't need to be those 2 points. It can be those 2 points, but it doesn't necessarily need to be those 2 points. It's whatever 2 points you think best represent the line that represents the correlation there. Do we need more time? Are we still working on our line of best fit? Yes? All right, I'll give you maybe 30 more seconds. I'm going to talk through it, and then we got a couple more pieces to do on this problem. So you just have to check yours on when we do the linear regression calculator. We can see how close to our line the best fit under their linear regression. Alright, so if you use the same points as me, if you use the first point and the last point, you should get y equals 29.2x plus 692.8. If yours is different than that because you use different points, that's fine, right? It's going to be. Just make sure you show your work, so if on a test you have to do a problem like this, I can follow your work, make sure you did it correctly. Right? Because everyone's line of best fit is their own approximation. Now, what's going to happen here in a second, we have another part to do, but then we're going to do a linear regression in the calculator. And the calculator is going to be very, very, very close to being dead on. Right? So we're going to get to see how did our line of best fit compare to the calculators. Alright, so before we do that though, part 2, use this line. Approximately how many people attended the 8th game? Well, how could we figure that out? Plug 8 in for x, right? Our x values are how many games we've had. So if I check my line of best fit here, I can plug in 8 for x. So y equals 292, or 229.2 times 8 plus 692.8. Now, like I said, if your line of best fit is a little different than mine, you might get a different approximation. That's fine. Did anyone plug this into the calculator by chance? 926. I assume it's a rounded number, which is perfectly fine because you can't have 0.3 per person. You probably get thrown in jail if you do. Right? You show up to the football game with someone's legs, probably get thrown in jail. Alright, so 926 people. If you had a different line of best fit equation, were you somewhere near that number? Yeah, you should be. You should still be pretty close. Right? It's just your approximation is a little different. Now, what we're going to do is get our calculators out. And we're going to do a linear regression. So, what that looks like is, go to your y equals. Make sure everything is cleared out of it. And when you do that, I want you to go up to plot 1 and hit enter. What that does, it turns your stat plot on. So when we put our list in, our x and our y values in, it's going to actually plot those points on our graph for us. Alright? So, once you've cleared y equals, so you hit y equals, you've cleared them out, you've turned your plot on, we're going to go to stat, and we're going to click edit. In list 1, you're going to put all of your x values. So in this case it was 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7, enter. Right? Those are all your x values from this problem we just did. The same football problem. And all my y values are going to go into list 2. So it's going to be 722, enter, 763, enter, 772, enter, 826, enter, 815, enter, 857, enter, and 897, enter.
Where's stat?
Sorry, right here, right below delete.
Oh.
Okay, so you just, I'll let you guys catch up. So go to y, you need to make sure everything's clear out of y equals. Make sure your plot is turned on. And list 1 and list 2 need to be filled out with your x and y values. Okay? We good so far? See? We? Alright. Then our next step is we need to find the linear regression, which is AKA, it's the really, really good line of best fit that the calculator does. Okay, so we are going to hit stat. We're going to go over to calculate. And the fourth one down is linear regression. Be very careful. You'll notice there's another linear regression down here. Why do you think we choose the fourth one and not the eighth one?
Because of the equation.
Because of the equation, right? mx plus b, not m times bx. Right? So you need to choose the fourth one here. When you click on it, it's going to pop something up. Oh, come on. Come on. It's going to say x list, y list. Well, where you put your x values, you're going to put that list in. Should be list 1. Where you put your y values in, it's going to be list 2. If you need to change that, you need to hit second, and then if you look right above 1 and 2, is L1 and L2. Those are your lists. Okay? Is yours a little different?
Yeah.
Okay, I'll be over there in 1 second. You do not need anything in your frequency list. Do not have anything in your frequency list. We are not worrying about storing the regression. All you're going to do is you're going to hit calculate. You're going to notice it gives you an A and a B value. You're going to write those two things down. Right? I would write A equals 27, B equals, and let's round it to the hundredths. 699.43. Because what you notice, up top here it says y equals ax plus b. So what you can do then, plug in a and b. Y equals 27x plus 699.43. Sorry, that's really squeaky. And now look, we have an equation for a line. So this is the calculator's line of best fit. It's called linear regression. So I think that's the third part of the question. It asks you find the linear regression equation, right? Now step 4 wants you to estimate how many people will be at the 8th game using that equation. See how close you were. See how close your line of best fit was by testing it against the calculators. Alright? Did I lose anyone? Lost you guys because you have different calculators?
I was still doing whatever.
Okay, sorry. So we stat, calculate, fourth and down linear regression. What you're going to do then is you're going to hit second, L1, second, L2. Okay, so you're calculating that. So stat, linear regression, L1, comma, L2. And hit enter. It should pop up. Did you hear that? Okay. You sure?
Yeah.
Okay. So you guys, get your list in. So you need linear regression pop up for that. You're going to hit second, is it L1 is right above the 1. And comma, second, L2. So whatever list your x's are in, you put that first, comma, whatever list your y's are in. No parentheses. You hit enter, and it pops up your A and your B. Okay? Okay?
Yeah.
Is there anyone else that needs help with their calculator? Alright, did you figure it out? What's up? Do you need help? I thought you raised your hand when I said you need help.
No, I didn't.
Okay. Guys, what did you get for an approximation of people?
That's okay, Mr.
915.43? So like 915? So the calculator estimated what, 915 people? We estimated, or I estimated based off my line of best fit, about 926. That's pretty close, right? We're not dead on, because we're not exact people, right? We're approximating, but we're really close. All right? Yes, ma'am.
So when I did run at different points, I have like 1,042 people.
Okay.
Would that be?
So, as long as you show your work and you show me what points you use. Now, if you go up here and when you draw your line of best fit, because you do need to draw a line of best fit on there, if say it was on a test, and you draw a line of best fit that looks like this, you're going to get it marked wrong. Right? But if you're close and I can tell you're trying, you have the same amount of points above it as you do below it, that's fine. It's going to be a little different. It's an approximation. I get that. Alright? Cool? Any other questions? Okay, we're not going to do all of the next problem. All I want you to do is I want you to find the linear regression for this. We're not going to work about line best fit. So go into your calculator, put the study hours as your X, grades as your Y, And I want you to find the linear regression in your calculator. So put them into your list. Do the linear regression, write down your A, write down your B, and create your equation. Guys, just assume to round to the hundredths at this point. I know it doesn't say it. Let's just assume that from now on. Okay? So round to the hundredths. I believe it should be written on a test. So like I said, find your linear regression, find the equation, and then go from there. Okay, so then you go to stat, calculate, linear regression. Then L1 and L2 are good, right? Then calculate. Okay? Do we have any questions? Anyone having struggles with their calculator? No? Are we all to the point where we found our estimate already? We're still working. Did we all get 99.91 for our grade? Not hours. Alright, so that is how we do line of best fit by hand, right? That is your approximation. Line of best fit is your approximation. Linear regression is the calculator's best approximation, which is really, really close to be exactly correct. Now, something really cool on your calculator. I don't think we'll ever ask you to actually use it, but if you go into here, so I'm going to use the first problem as my example. If you go into your y equals and you put in that linear regression that we found, was it 27x plus 699.43, and you plug that into your first y equals and you hit zoom, and the ninth one down is zoom stat. It'll plot all the points and it'll put that linear regression line on there for you. So you can kind of see the calculator's line of best fit. Pretty cool.
Where's that?
So if you do that, if you plug in, so let's say if you had plugged in the one for the last problem, after you put your list in, and you go to zoom and you go to zoom stat, it'll show you all the plotted points and that linear regression on there. Alright? Like I said, I don't know if we'll ever actually ask you to use that, but it's there. Cool? Any questions about linear regression, about line of best fit? Cool. Subscribe. Swipe up. Smash that subscribe button, Larson. Alright.